All right, inverse trig functions. So we did our regular trig functions, graphing all 6. Now we're going to go into looking at evaluating inverse trig functions. So we've already done before. We take sine of an angle and it gives us a ratio. Okay, we are going to inverse trig functions. With inverse trig functions, what you're thinking of is we're taking a snapshot of the function, because in order to have an inverse, it has to be 1 to 1, which means our inverse function has to pass the vertical line test. So we are chopping off a good segment of the graph of sine before inverting it to create the graph of inverse sine. So what we want to do is think of inverse sine as the angle in the range negative pi half to pi half, whose sine value is the ratio x. So everything's trading places because inverses x and y switch. So the inside of inverse sine represents a ratio. We take the inverse sine of a ratio to get an angle. So I like to think of inverse sine as far as where it's allowed to live. You could say, I had a coworker tell me the closed half moon. A class came up with one year. Sideways dead man. So what that sideways dead man means is I can have any angle directly up into quadrant 1 or directly down into quadrant 4, but I may not go through the dead zone in order to get to quadrant 4. So what that means is if you're trying to put an angle in quadrant 4, you are not allowed to swing around and stop here. So instead of going counterclockwise, you would have to go directly to it using a negative angle. So inverse sine lives in sideways dead man. All right, evaluating. So first one we're asked to evaluate is the inverse sine of 1/2. So again, remember, this is a ratio. That's not zoomed in enough. Can't write very small. Which means our answer is an angle. So what we're thinking of is I want the angle in sideways dead man who has a sine value of 1/2. Okay. Well, a sine value of 1/2, if we think about sideways dead man, I'll draw a picture for this first one. So these are no-no zones. So I can be anywhere in here. If y is 1/2, again, that unit circle is coming back hot and heavy. If y is 1/2, that's this angle right here, because y is the short side. So the angle pi 6, we're going to stay in radians. So inverse sine of 1/2 is the angle pi over 6. B, inverse sine of negative square root of 2 over 2. So once again, stop changing colors. There we go. This is a ratio. This is an angle. All right, so what we're thinking, we want the angle in sideways dead man. So if you're visual, draw to give you something to look at. Mark your no-no zones. I want the angle in sideways dead man whose sine value or y value, because this is a unit circle ratio, is negative square root of 2 over 2. Well, negative square root of 2 over 2 would be right here, but remember, you are not allowed to go through the dead zone, so do not answer 7 pi fourths. Instead, go directly to it, negative pi over 4. C. This is a ratio. Our answer is an angle. So I want the angle in sideways dead man whose sine value, or it is a unit circle ratio, y value is 0. So I want the angle in this zone whose y value is 0. Well, that's the angle 0. That's not drawn very well. That's the angle 0 right here. That's where y is 0. So the answer is the angle 0. Inverse sine of the ratio 0 gives us the angle 0. Inverse sine negative square root of 3 over 2. Inverse sine, this is a ratio. Our answer is an angle. I want the angle in sideways dead man whose sine value is negative square root of 3 over 2. Negative square root of 3 over 2 means I've got to be down here. Negative root 3 over 2 means y is the long side, but I am not allowed to go through the dead zone. So instead, I go straight to it. Negative pi third. All right. Inverse cosine. So same idea with inverse cosine. We're going to take a snippet of the graph of cosine so that its inverse will pass the vertical line test to be a function. So inverse cosine, the inside still represents a ratio. Our answer is an angle because everything trades places, but it lives in a different region. So inverse cosine is upside down dead man. Or you could, if you want to be a little happier, the sunrise. So we're going to change colors. So you could say the sunrise, upside down dead man. We'll do everybody in terms of dead emojis. All right, so inverse cosine lives in upside down dead man. That means you can have any angle in that region, but you are not allowed to answer in the dead zone, nor are you allowed to go through the dead zone. All right, let's get going. Inverse cosine of the ratio 1/2. This is a ratio. This is an angle. Okay. I want to know the angle in upside down dead man, if I can draw straight lines, whose cosine value or unit circle ratio, x value, is 1/2. So the x value being 1/2, well, we've got x is square root of 3 over 2, x is square root of 2 over 2, x is 1/2 right there. Angle pi third. Inverse cosine, negative square root of 2 over 2. You know what? We're going to be lazy now. I'm tired of writing these over and over. This is a ratio. The answer is an angle. I am looking for the angle in upside down dead man. So no zones, whose cosine value, or this is a unit circle ratio, x value is negative square root of 2 over 2. Well, negative is in here. Negative square root of 2 over 2 is right in the middle. That is 3 pi fourths. That's good. Third one. This is a ratio. Our answer is an angle. So I want to know what is the angle in upside down dead man whose cosine value, this is also a unit circle ratio, so x value is 0. Well, the x value is 0 right there. That would be pi halves. All right. This is a ratio. Our answer is an angle. I am looking for the angle in upside down dead man whose cosine value or x value is negative square root of 3 over 2. So negative is in here. This is negative 1/2. Negative square root of 2 over 2. Negative square root of 3 over 2 is that lower angle. That lower angle is 5 pi 6. Right? Inverse tangent. All right, inverse tangent. Inverse tangent is the angle. It looks very, very similar to inverse sine with one little change. Notice the parentheses on your interval for your angle. With sine, it was brackets. So sine was sideways dead man. Inverse tangent is sideways dead man with dimples. So we're going to put some, I'm going to change colors. Sideways tangent, inverse tangent, sideways dead man with dimples. What that means is we are not allowed to be at negative or positive pi halves. We have to be inside of that range. So be very, very careful with that. All right. Exact values for each. Once again, angles versus ratios. This is a ratio. Our answer is going to be an angle. I want to know what is the angle. So I might take a little practice. Let's go ahead and get, you know what, I'm going to be lazy again. I'm going to copy dead man dimples to each of these. That'll just speed it up. Copy, paste, paste, paste. Okay. All right, now back to the first one. All right, so I am looking for the angle in sideways dead man with dimples whose ratio is 1. Tangent's ratio is y over x, so the tangent might take a little bit more work. Y over x being 1 means they have to be the exact same and same sign. Well, the only place in sideways dead man with dimples where they're the same sign is in the middle of quadrant 1, which is with the angle pi 4. Negative square root of 3 over 3. All right, so like I said, tangent may take a little bit more work. So before I start trying to find this angle, I know this is off the unit circle, but it might be hard to recognize what x and y are. So we're going to work backwards. You should be able to recognize that this ratio has been rationalized. So first off, let me get my, my angle and ratio labels back, because those are very helpful. So let's copy again and stick them back on here. Ratio, angle. But the next thing I want to do is I want to unsimplify that angle, because remember, all of those ratios have 2's in the denominator. That's been rationalized. I want to unrationalize it to make it very obvious what x and what y are. So the ratio negative square root of 3 over 3 has been rationalized. So to undo it, we just simply put it back on the bottom. Then I'm going to slide it apart a little bit further, and I'm going to slide the 2's back. Remember all those 2's that divided out? We're going to put them back. And then as far as the negative is only allowed on one of them. In sideways dead man, the negatives are going to be down here, which is where y is negative. So tangent, the negative will always go into the numerator because the dead zone is where x is negative. So I am looking for the angle in sideways dead man with dimples whose ratio, tangent ratio of y to x is negative 1/2 square root of 3 over 2. So that means x is square root of 3 over 2 and y is negative 1/2. Do not go through the dead zone to get it. Go straight to it, negative pi 6. So I think this little algebra manipulation on that ratio is very helpful to get it back to recognizing where those unit circle x and y values are, unsimplified. All right, next one. This is a ratio. Our answer is going to be an angle. So we are looking for the angle whose tangent ratio, tangent is y over x, is 0. Well, if the ratio of y to x equals 0, well, the only way to get that to be 0 is if y is 0 and x is some other number. So in sideways dead man with dimples, the only place y is 0 is right here, which is the angle 0. All right, D, inverse tangent of the square root of 3. Inverse tangent of the ratio negative square root of 3. I think I said positive. All right, so once again, you should recognize this is a unit circle ratio. I'm going to put it back. It's not rationalized. It didn't need to be, but the 2's were still divided out. So I want to turn that back into the unsimplified unit circle ratio. So that means putting the 2's back on the square root of 3 and putting the 2's back on the 1. As far as the negative, remember the negative's got to stay with y because x negative is in the dead zone. So we are looking for the angle in sideways dead man with dimples whose y is negative square root of 3 long and x is positive 1/2 short, which would be negative pi thirds. Do not go through the dead zone to get to it. So we have to go this way. All right, so bringing them all together, here's some properties of inverse trig functions. Be very, very mindful of these. They only work if it is a valid ratio and or the angle is in the correct quadrant. If the angle is not in the region you're allowed to live in based on it being inverse sine, cosine, or tangent, you have to move it. Okay. So a quick little summary on where things are allowed to live. Here is your inverse, actually we're going to copy real quick, copy. All right, inverse sine, sideways dead man, dead zone. Inverse cosine, upside down dead man, dead zone. That's dead man. And then inverse tangent, sideways dead man with dimples. So dead zone, dimples. That means I cannot be on those here. So sine and cosine have closed endpoints. Tangent has open endpoints. You have to be in those correct regions in order for these to work. So A, sine of inverse sine of negative 0.53. So what you need to make sure of is watch your angles versus ratios. So inverse sine is on the inside, so that means this is a ratio. Ratios are valid when they are in the closed interval negative 1 to 1. That ratio is valid because negative 0.53 is in there. That means we are going to get the exact same ratio back out for our final answer. As long as the ratio is valid, you get the same answer. Right, B, inverse tangent of tangent. Watch the notation here. Tangent is on the inside, so what that means is this is an angle. Oh, I wanted an arrow. However, this angle we need to make sure is in the correct zone. So I'm going to look at my inverse tangent. Inverse tangent, sideways dead man with dimples. Dead zone. Negative 4 pi over 3. So here is negative, whoa, that's not what I want to draw. There's 0, so there's negative 1 over 3, negative 2 over 3, negative 4 pi over 3 is here. That is in the dead zone. It's not allowed. So we are not getting the same angle back. So we need to go figure out what the angle would be in the region we're allowed to be in that would have the same tangent value. So we know it's going to be over 3. So what we want to look at is the value of tangent. In quadrant 2, tangent is less than 0. So I need to go to quadrant 4 where tangent is also less than 0. So what I want to do is simply just mirror this angle over like this. So instead of swinging all the way up, we are just going to stop here because those two angles have the same tangent value, and negative pi thirds is in sideways dead man with dimples. So the angle is going to be negative pi thirds because the angle is not valid. This angle that we are given is not in the open interval negative pi half to pi half. So we have to find the equivalent angle. All right, C. So if we look at our notation, inverse cosine on the inside, so this is a ratio. Inverse cosines ratios are in the closed interval negative 1 to 1. If I look at the ratio 2, it's not. What this means is that we have a broken triangle. You cannot fix a broken triangle, but you can move an angle. So because we have an invalid ratio, this does not exist. We can't fix the triangle when it's broken, but we can move the triangle to a different quadrant. So in part B, we moved the triangle from quadrant 2 to quadrant 4. With C, our triangle is broken because what it's saying is our x value is 2 and our r value, which is the hypotenuse, is 1. Well, if x is 2 and r is 1, it doesn't matter what y is, I can't draw this triangle, it's broken. Right? Inverse sine of negative pi thirds. So this is an angle. The angles for sine live in the closed interval negative pi half to pi half. So that would be sideways dead man. Negative pi thirds is in sideways dead man, which means we don't need to worry about moving it. It's our answer. As long as the angle is in the right region, we get the same thing back. If it's not, we move it. All right, negative. Inverse cosine of negative pi 6. Cosine on the inside, so this is an angle. Having issues with my arrows today. Our angles are allowed to be in for cosine. Closed interval 0 to pi. This angle is not there, so we have to move it. All right, so the angle, or where we're allowed to be, I'm going to go ahead and draw where we're allowed to be. We are allowed to be in upside down dead man. So that would be this region. We cannot be here. So the angle we're given, negative pi 6, is right there. Actually, let's go pink. I like the pink better. So what we want to know is cosine in this quadrant. Cosine in this quadrant is positive, so I need to move to the quadrant where it's going to stay positive, which means we're going to mirror it up right here because cosine is also positive there. So negative pi 6, we are going to use the angle pi over 6 because it's in the correct region. All right, so everything we've done thus far has been sine paired with itself, cosine, thus vice versa. Now we're going to start mixing everything, okay? All right, first one. Sine of inverse cosine of negative square root of 3 over 2. So we're going to take these in stages. So first one here, inverse cosine is on the inside. So this is a ratio. So I am going to evaluate inverse cosine of that ratio. So I need the angle whose cosine value or x value is negative square root of 2 over 2. So again, if you need to draw a picture, draw a picture. Upside down dead man because we're dealing with cosine. Negative square root of 2 over 2, right in the middle here, that is 3 pi fourths. So inverse cosine of negative square root of 2 over 2 is the angle 3 pi over 4. We evaluate the inside. That's a large set of parentheses. Then we take the sine of 3 pi fourths, and that's straight unit circle. So we don't have to mess with inverses when it's just regular trig. Sine of 3 pi over 4 is square root of 2 over 2. So our final answer, square root of 2 over 2. So work your way from the inside out, just like any other expression. Next. All right, regular sign on the inside. So this time it's flipped. We go to the inside straight unit circle. Sine of 5 pi thirds. Again, if you need a little picture, draw a picture. 5 pi thirds is right here. The sine value there, or y value, is negative square root of 3 over 2. So this is an angle. Now that we're here with inverse cosine, this is a ratio. So inverse cosine, I am looking for an angle who lives in upside down dead man, whose cosine value is negative square root of 3 over 2. Negative square root of 3 over 2 for x is going to be 5 pi 6. So our final answer, 5 pi 6. See? Cosine of pi, regular trig on the inside, so this is an angle. So the inside expression, straight unit circle. Cosine of pi is negative 1. Then we bring our inverse tangent down. Now, this is a ratio. So I am looking for an angle in Sideways Dead Man with Dimples, whose tangent value or ratio of y over x is -1. Well, up here, that's +1. So down here in the middle is -1. So that is negative pi fourths. Next. Inverse sine inside, that means we are dealing with a ratio. So for the inside, we are looking for the angle who's in Sideways Dead Man, whose sine value is -√3/2. So y -√3/2 is negative pi over 3. Then we drop the outside down. Cotangent of negative pi over 3. Well, that's just cotangent's the ratio of x to y. So cotangent, this ordered pair, whether it's negative pi third or if you go back to 5 pi thirds because they're coterminal, that ordered pair is 1/2 comma -√3/2. So ratio of x to y is going to be 1/2 over -√3/2. 2's drop, and we got to rationalize, so move it up and drop it on the bottom. -√3/3. E, tan sine 2 pi. Notice there's no inverse here, so let's see how we're going to approach it. Sometimes we get some that's got double identities. So sine is on the inside, so that means this right here is an angle. So straight unit circle evaluation. Sine of 2 pi is 0. So then we drop tangent down. Because tangent is on the outside, this 0 magically goes from the ratio 0 to the angle 0. So it's got zeros have double identities. Tangent of 0, that's just another unit circle evaluation. Tangent of 0, ratio of y to x, is also 0. And then F, we got a little triple one here for fun. Again, work your way inside out. Sine of 3 pi halves, regular sine. So this is an angle, straight unit circle. Sine of 3 pi halves is -1. I'm going to drop them down one layer at a time. Tangent of -1. The inverse tangent, so I'm looking for the angle, because that's a ratio. The angle in Sideways Dead Man with Dimples, whose ratio of y to x is -1. Well, that is negative pi fourths. Now I drop the last layer down. Secant. Secant is 1 over x. Well, the x value, this ordered pair, the ordered pair is √2/2 negative √2/2. So if I take x, turn it upside down, we're going to get the square root of 2. So a lot of heavy unit circle in here. If you need to, go back and review your unit circle. All right, last thing we're looking at is creating algebraic expressions. So we can also use these rather than just numerical values like we've done up at the top here. We can use algebraic expressions to figure these out. So use a right triangle to write each expression as an algebraic expression. Assume that x is positive and that the given inverse trig function is defined for the expression x. So we're just going to make it simple. X is positive. That way all our triangles are drawn the same. All right, so first things first, inverse trig on the inside. This is a ratio. What we then do is we take inverse trig of this ratio. So we've got our inverse trig of this ratio. That is going to give us an angle. We take cosine is regular trig. We take regular trig of an angle, which means our final answer is going to be another ratio. That's why it says algebraic expression, because our final answer here is just going to be an algebraic expression similar to the one we were given of 2x. So what I want to do is get a right triangle drawn. So here is my right triangle. I'm going to go ahead and mark my angle theta. I always use the lower angle here. All right, so tangent is the ratio of the y side to the x side. So the ratio of 2x is 2x over 1. So that means that the y side is 2x and the x side is 1. Well, in order to do trig of the angle, the cosine of that angle is going to involve the x side and the r side. We need to go find r using Pythagorean theorem. So this r side here, remember r is the y side sum of squares of the two legs. So 1 squared plus 2x quantity squared square root. So we're using Pythagorean theorem here. So r is 1 plus 4x squared under a square root. So we did inverse tangent of the ratio 2x to get the angle theta from our triangle. Cosine of the angle theta is the ratio of the x side, which is 1, over the r side, which is 1 plus 4x squared, all under a square root. Once again, algebraic expressions need to be rationalized. Move it up and drop it on the bottom. So I'm going to move my 1 plus 4x squared up, and then I'm going to drop it on the bottom. So rationalize your answers. All right, B. A little more complicated here. So when you're given this complicated ratio, you should be able to recognize when it involves a leg versus it involves r. So the key with involving r is a sum. So when you're dealing with a sum, you're given the hypotenuse. When you are dealing with a difference, you are given a leg. So for this one, inverse sine. So this is our ratio, which means we're going to do inverse sine of said ratio. We're going to get the angle. We're then going to take regular trig of our angle, and our final answer will be another ratio. So we need to build our triangle. There's my angle theta. All right, so getting this thing taken apart. Sine involves a leg and the hypotenuse. So sine is the opposite leg. So the opposite leg is going to be the x squared minus 9 under a square root. The hypotenuse is the denominator, x. Okay. So here we can solve for our missing side using the Pythagorean theorem, but that's going to be kind of ugly. So what you could do instead is, if you're able to take this apart, this right here is the square of that missing side. That missing side is its square root 3. Because the only way to get that other leg is to take the square of the hypotenuse minus the square of one of the given legs, so it has to come out to 3. So we're just going to take it apart. All right, cotangent. Cotangent is the ratio of the x side to the y side. So the x side is 3 to the y side, x squared minus 9 under a square root. Lovely. And then again, we have to rationalize, so we are going to move it up. And then we're going to drop it on the bottom. Looks a little bit ugly, but it's mathematically simplified now. So the key is for these, get that triangle built correctly and use the characteristics of given sides to find missing sides.